Okay, so we're at this issue then, hopefully with the last written lecture video and the model there, you're convinced that the moon doesn't have its dark side. There's just no way it can. The sunlight will reach the side whether the moon is rotating or not. But of course the moon does rotate. So the question then arises then, how is it that the moon has the same side that faces us? So once again, I have a pair of videos for you here. One is a little bit of setup, which I'm giving you now, and then I'll show you another model similar to the last one to show you where that same side could come from. Well, it sort of works like this, just to cut to the chase here. Once again, you have the sun, which of course provides us with all the wonderful light that we have. And then here's the earth here like this. And then I can get a little bit of a gray here maybe and say, okay, here is the moon. Again, I'll draw the moon sort of over here. And as you know, the moon does its orbiting around the earth. Okay. So how is it that the same side could always face us here on earth? So in other words, if we're standing here on the earth, say right here, how is it the same side could see us as we sort of look up? We sort of look up this way, how is it that we always see the same side? Well, it's going to go like this. Suppose that the moon was here, as I've shown you in the picture right here. And let me maybe draw a little bit of any light, sort of an equator in there or something. And I'm just going to say that here's the side of the Marea here that we always seem to see, those dark splotches, right? And then what happens is as the moon orbits a tad bit, it might make it over to here. There's the moon in its new position. But for some odd reason, the Marea that are right here on this side stay sort of in their same position facing us as the moon goes over there. And as the moon, say, makes it over to here, here's that equator once again. Once again, this Marea that was over here and we saw here will now appear over here. So there's those dark splotches of the Marea again. So the point is that every time we look at the moon, whether we're in this position here, or we look up from this position, or we look up from this position, we always see the side with the Marea. And so from those three figures alone, I wonder if you can just look at it very carefully and tell me what the answer is. Why is it that the same side of the moon always faces us? Why is that? I hope some of you sort of came up with the answer. So you know that the moon is orbiting like this, has sort of some speed that it orbits, or whatever, maybe some we'll call it some speed v that it orbits, the v suborbit if you want. But the moon also rotates. It does both of those things. And what we're sort of supposing is that, suppose that somehow these two things, in other words, suppose that these two things here, in other words, the orbit and the rotation were linked. That's kind of an interesting, maybe something that could happen. Maybe they're linked. In other words, maybe something about this speed at which it orbits all the way around the Earth is somehow related to how fast it rotates. And maybe you're seeing what has happened to the moon here, or what the state the moon sort of exists in here. This speed here is linked to this orbit here. It definitely is. They are linked in such a way that the same side always faces us, and I think you know that by now. But the point I'm trying to make is that by the time the moon, they're so linked that by the time the moon makes it all the way over to here, almost back again, where it started after going all the way around, here's the moon again, it's almost exactly back into that same orientation. So I'm going to draw this eclipse, this sort of equator that I've been drawing. I won't draw it straight across here like that, because that's where it is when it's here. Let me draw it just a little bit off being straight across, and assuming that the moon is orbiting that way. Let's just say that that line is sort of like just right around there. And the Marea maybe are still pointing straight towards the Earth like that. That's the side. So the reason why I drew it like that is so when the moon here just rotates just a tad bit more in the direction of this arrow here, this equator will be lined back up with that equator, the Marea will be lined up with the Marea, and the cycle will continue. This can only happen, this sort of alignment can only sort of happen if the time the moon takes to orbit is equal to the time it takes for the moon to rotate. So in other words, yes, it takes 30 days for the moon to orbit the Earth once. It also takes 30 days to rotate once. And that's sort of the situation. The orbit and rotation time are linked in such a way that the orbit time exactly equals the rotation time. So I can show you something a little better than my drawing now, which might illustrate the point. So what we have here sort of is a simulator, and what I can do, just to show you what this does, is kind of a nice animation here, is it sort of gets everything going here, gets the Earth rotating, and gets the moon moving around in its orbit. Now you can't really see the moon's rotation all that clearly on this, either because just the graphics, there aren't any features, but cleverly, if I go back to where I started, what they allow me to do is turn on a landmark on the moon. Now I don't know what this is, it's just something sticking up like a tower, but it allows you to see the dynamics that I'm telling you about. So if I sort of run this again now, you're looking at it, so look at it very carefully and see if you can judge for yourself, is the moon rotating in this video? Is it rotating? And well, the answer has to be yes, because look at this landmark here. Here the landmark is pointing up. And look, when it was over here, the landmark is pointing to the right. Now it's pointing up. So yes, the moon must be rotating because that landmark is rotating. But if I let it continue, if I let it continue, let me let it go, there we go. You can see that it's always rotating in such a way that by the time the moon goes all the way around back to where it started again, all the way around, look at that landmark pointing due right again. And this is the story of the moon then, why we always see the same face. It's about as fast as I can run it there, and you can see that of course the moon is rotating there. And of course there's no strict dark side. You can see that all the areas of the moon, again, there the structure or the landmark is in the dark. Now there it's just coming into the light again, and then it goes into the dark again or whatever. But the point is that that same face of the moon always points us because the orbital time of the moon is equal to its rotation time. And that's not a coincidence. It's actually something that we have to explain in a coming video, but that's why we always see the same face of the moon. So again, just to recap, there is no dark side, but the moon's rotation is locked to its orbital time, and we always see the same face.